welcome to the Knowledge Graphs 101 webinar from Graphable. Subtitle, what are they, how do you make one, and how can they benefit your organization? I figured I'd get started by actually doing a bit of an intro here. So I'm Kyle McNamara, CEO of Graphable. Got Will Evans as well, VP of Strategy and Innovation. I'll be doing a bit of an overview, and then Will be doing a demonstration. So to give you a thumbnail on Graphable and our core competencies, just so you kind of know who we are, we focus on Neo4j, graph databases, graph analytics, graph data science, machine learning, natural language processing, knowledge graphs, graph-based application development, so custom apps with graph at the center, traditional analytics, as well as data integration and data strategy. So if you have questions along the way, there should be a question and answer button at the bottom that looks like that little image that I set on there. And you can ask your question. We'll get to as many as we can at the end of the session. So to get rolling, in order to put knowledge graphs in context, we want to start with the question, what are graph databases and why are they needed? So another question you could start with is just, where do they even come from, right? So if you think about the history, it's the mathematics around network science have been around since the 1700s, but it really hasn't been, if you look at the x-axis here, since 5 or 10 years ago that it started to become more pervasive in the enterprise. And if you look at the interest level in graph databases over the last 5 to 10 years, it's really outstripped all the other data stores by a significant factor. So an important question, what are they and how are they different? I've kind of boiled this down to the question of both intent and magnitude. And when I say intent, I don't mean, what's the intention of, inside the data, but what's the intent of the application? So for recommendations, or is it, finding who knows who in terms of like fraud analysis? So it's the intent to find connectedness and relevance, and it's the magnitude of any significance, right? Because there's a lot you can do in relational databases mimicking what a graph can do, but once you get to any kind of scale, it becomes much more difficult to make it performant. So we can use a classic graph database use case like recommendations. There's a lot of people with skills around relational databases, and the first question they ask is, why not just use a traditional relational database? It's pretty easy to answer. It's inefficient for these kinds of graphy so-called use cases that involve connectedness and relevance. The SQL language itself is not structured or optimized for finding relevance or connectedness or directionality in the data. Even the objects themselves, tables and rows, it's just not set up for that in mind. On the other hand, graph databases principally store only data relating to the kinds of questions being asked. And they're optimized for asking those kinds of questions relating to relevance, connectedness, directionality. The data is stored natively as a connected network in an actual native graph database like Neo4j. Most of the other databases out there are not native graph databases, and that has different implications. But it makes it quick, often in the milliseconds, to traverse millions and even billions of entities and relationships. It enables us to quickly and efficiently find relevance between those entities. I found this, I think it was a blog article from Neo4j from years ago showing this great example of relational versus graph. And it's a simple one, but it's very telling. If I want to find how Alice is related to the departments in the organization, I'm going to have to typically go through some kind of lookup table or a join table and look at the associated SQL statement. It's 2 or 3 times the length of a cipher statement, which is purpose-built to find that connectedness or relevance. You look down here in the graph model below, you can see Alice could belong to a future, past department, and it's very easy, right within the structure, let alone the cipher statement, to find that connectedness. Found a great article called The Continuing Rise of Graph Databases by Zdnet, and I thought they really captured it well. The idea of using stores with data models that best align with the problem at hand is becoming increasingly popular and understood. So it's not about using graph databases for everything, but rather a lot of the questions being asked today that organizations are asking of their data and at the scale they're asking it, so that question of intent and magnitude, it requires data to be stored as a connected network in a graph database. So now we've given a little bit of background on the graph database side of things in order to position knowledge graphs. Let's dig into that side of things. What are knowledge graphs? And the question is debated, and for good reason. You're looking at a graph, a chart here from Gartner, the hype cycle for emerging technologies. And to underscore the fact that it is an emerging technology, in 2018, this is where, if you kind of look down here, where Gartner positioned knowledge graphs as a concept in the enterprise. So it's something that's unfolding right in front of us, and there's going to be a variety of perspectives, and we'll bring ours here today. So the question is, how do these knowledge graphs relate to graph databases? Because they're interrelated, but they're not the same. Like all databases, a graph database is simply a data store that requires development effort to create an asset that can be used as the underpinning of a business application. The knowledge graph asset itself that ultimately becomes invaluable to organizations is the asset that is created and stored in a graph database. The best example I've found is it's similar to how relational databases could store, for example, sales data that can become even more valuable when, for example, a CRM or customer relationship management system leverages that data to organize, track, and process our sales pipelines. In the same way, a knowledge graph is an asset that sits on top of a graph database. So now we get into a little bit more of the significant differentiation of a knowledge graph from other kinds of graph use cases. And again, this is our perspective on it. A knowledge graph essentially becomes a digital twin of an organization or an aspect of an organization. Think of HR, for example. And that's in the sense that it more accurately represents the real world, how entities, people, partners, sales, products, locations, think of your dimensions in your business and how they're actually connected in real life. And this, in turn, opens the door to answering questions that are difficult, if not impossible, to answer at scale before, right? So with the intent of finding relevance and connectedness at today's scale of data, right, a certain magnitude, this is where it becomes really, really valuable. And then finally, Graphable in particular is pioneering using unstructured data to achieve the true potential of knowledge graphs. And our approach, we believe, distinctly sets knowledge graphs apart from other graph database applications. And it's important because I believe Gartner said it was around 80% of your data is actually semi-structured and unstructured data. And in most cases, it's really not being used, right? And there's huge value and potential for differentiation and competitive advantage, but it's very difficult to work with. So we believe, leading edge natural language processing, machine learning used to identify and store the parts and meaning of the unstructured text is critical to building an actual knowledge graph. It's very difficult to do, though, and we'll talk about how we can lower the bar significantly in the demonstration. Enriching existing domain data with internal and external sources. So think, I might want to enrich my internal domain information with legislation externally, ConceptNet, Wikidata, maybe a financial data store that is available publicly that translates acronyms to the full name, that makes it specific to my domain. And then leveraging ontologies and taxonomies. This sounds fancy, but really they're maps of things to bring domain relevant points of view to your knowledge graph, points of entry to the knowledge graph, and really efficiency in traversing and just additional order to that knowledge graph. And lastly, knowledge graphs should be self-learning. This is really looking towards the future. We can use knowledge graphs to discover the things that we think we know we want to understand about that data. But once you've set something up like a knowledge graph with your unstructured data, we can use machine learning to really uncover the unknowns, right? Highly valuable unknowns that is just buried in this massive data that's inside our organization. So a practical example of a knowledge graph, a little known but massive scale, is Google. There's not a lot of official information about how Google created and maintained its knowledge graph, but as of 2016, there was something like 60 billion connected facts there. So the question is, how does Google surface value from such a knowledge graph for its users? For one, it underpins their newest version of its content ranking algorithm called RankBrain, which is much more effective than it's ever been as a result of the knowledge graph. And for end users doing a search, it's a highly relevant thumbnail, just one example of the value. That information, when you do a search, it actually suggests a kind of top result with an info card to the right. And if I look at, Neo4j as a search term, you notice this info card on the right, which is, basically appearing at lightning speed based on this knowledge graph. It's just a really good concrete example of where knowledge graphs are already in use today. Now we are, as Graphable, we are the exclusive reseller of GraphAware's Hume knowledge graph platform. And that's what we're going to demonstrate today, not because it's the only way to build a knowledge graph, but there are a set of capabilities that are really required to be able to manage, grow over time at scale, a knowledge graph that's really going to change the landscape of your organization. And so I'll just step through a set of capabilities that you'll see today through Will's demonstration momentarily, so you get a sense of what are the kinds of things that are required or even helpful to get to the place where I've got an actual knowledge graph in motion in my organization. And one of those things is the Hume labs, right? You need some way to transfer the domain expertise of your people internally, right? You've hired people who are experts and get that knowledge into the machine. So through a user-based, very simple to use user interface, collaborative environment, your lawyers or your doctors or whoever can actually annotate and link unstructured documents in a way that teaches the machine about your domain. And probably the most important thing is it takes existing models like Stanford NLP that come as part of the platform and combine them with your unique and specific domain information that's context specific to your business to drive up the overall accuracy and recall. And those are the two key measures in NLP, right? Accuracy and recall are the things that matter. And we see way above industry standard using this lab's capability. Orchestration. This is the ability to create an ecosystem of data. So whether that means I'm pulling from a Neo4j cluster and I'm pulling from a message queue of some kind, or I want to apply machine learning or some cipher statement or set of statements along the way, or write out to an Elasticsearch index, this really complex sort of ecosystem of points that represent the knowledge graph being created. That's what Orchestra is for. And you'll see an example of that. Graph schemas. Again, most people understand graph databases are considered a schemaless database, but in reality, humans don't understand databases without a schema. And so from the perspective of creating the database, designing it, understanding it, interacting with it, schemas are really valuable. And to our knowledge, we're first to market with that capability. NLP, so this is IP and expertise, right? So we've rewritten algorithms, come up with ways of assembling algorithms as far as ingesting unstructured data, all kinds of capabilities in the platform that is IP. And we also offer expertise. Natural language processing and unstructured data is never going to be a big red easy button activity. And we bring that expertise to the table in these contexts as well. Enrichment, we talked about that before. You're essentially compounding the value of your data with external or even internal knowledge bases. Machine and deep learning. Now, we're not talking about just using machine learning to build out this knowledge graph, but to also, in turn, find the things that you may not even know that you need to know, right? There's hidden value in finding the connectedness of your information across huge organizations, right? And I'm going to give you a really good example of that towards the end about a cruise company that had a really interesting use case where this is important to that context. Graph visualization, so best-in-class visualization. If you've got millions of nodes, that's not as helpful if you're an analyst or business user to try to find out what matters to you, right? So that's got to be a really important part of it. And then actions, the ability to encapsulate really, in some cases, very technical capabilities by right-clicking. So I could be a non-technical user and run a community detection algorithm on a set of nodes to drive out insights that I could never have done on my own. And we'll show you some examples of what that can be as well. So next, we're going to transition to a demonstration with Will. We've actually got a craft beer knowledge graph. Because we love craft beers here at Graphable, and we just thought it was a nice non-industry specific way for people to get a sense of how they might apply these techniques to their unique environments. So I've transitioned to Will, and I guess Will, at this point, if you could go ahead and start sharing.
Thanks, Kyle. So as Kyle mentioned, what we're going to be running through here is a craft beer demo. And really what we want to do as we walk through this is we want to start at the end with the result. And then we're going to walk forwards through all the steps that we had to take along the way to get there. We want to highlight the power of having a knowledge graph. So in our craft beer demo, we're looking at really a couple pretty simple things. And it's representative of a number of different use cases. So what we have in our data set is users who have reviewed beers, and the beers have a brewer and a style. And this use case really, though it's interesting to us in and of itself, represents a lot of broader similarity use cases, like finding similar high-performing employees, finding communities of feedback, recommending products. We've seen use cases around research in terms of recommending relevant research to the appropriate person at the appropriate time. And really what a lot of these things share in common is that they're sparse, high-dimensional data sets. So unlike some of the data sets that you see in more standard machine learning algorithms, we only have one or two reviews on average per beer, and each user has only on average reviewed one or two beers. So if we stick with our sort of standard machine learning algorithms where we try and say, okay, you reviewed basically 3 beers, and then let's find other people who recommended those beers, we're very likely to just end up recommending the most popular beers because they're by definition going to have the most overlap. And that's okay, but it's not the most effective way that we can go about this. So what we can do using a graph is actually even go further and increase the dimensionality of our system. And we can do that with things like pulling valuable information from our unstructured data using NLP, which is what Kyle talked about in sort of the middle of his presentation. So what's the result of all that effort? If we start with a beer, and look at something like a personal favorite of mine, the Blue Moon Belgian White, we can do something quite simple, like run an action to find a similar beer. And because we're domain experts, we can decide and actually weight in our graph the importance of flavor, texture, and appearance. So these are basically percentages, and I say, flavor is the most important to me, texture is second most, and appearance is really not that important. I don't care that my beer looks the same. I just want it to taste and have the same mouthfeel. And as I submit that, what we're going to do is we're going to leverage all of the information in our graph around the millions of reviews, the hundreds of instances of unstructured data that are being pulled back, and we're going to make a number of recommendations based on what we've requested in that weighting. And as we look at these results, we see that there's some similarity here. We have a Blanche de Brooklyn, which is also a wheat beer, similar to our Blue Moon Belgian White. We've got a Hefeweizen, which is another very similar wheat beer. But we also have a couple of sort of potentially odd results, like a Tire Chaser IPA. We wouldn't necessarily recommend, if you just asked me off the top of my head to recommend things similar to a Belgian White, I wouldn't come up with an IPA necessarily. But that's in our graph, and we'll understand at the end why we're making recommendations like that. And similarly, what we're able to do is we can also start from a different view. So we can look at a user, take our standard user, Mike drinks beer, and we'll see what he's reviewed. And as we look through this, we can see that Mike's had about 20 beers and he's reviewed them. So he's one of our higher reviewing users. And he's drinking beers within certain categories. there's a couple different categories, but he specifically is looking at something like an American IPA. And as we're leveraging the dimensionality of our data set, what we can actually do is things like split out the tokens in our style so that we see Mike looking at a number of American Blonde Ale and American IPA, and he's got an American Double. And what we're looking at here is maybe it's not actually the IPA piece that Mike cares about, it's the American piece. And so as we go and we recommend beers for Mike, we may want to not just stick with the style, but we can actually split that style into individual tokens and make new recommendations. And so as we look at our new recommendations, some are within the same style, but many are in different styles. We're looking at American Doubles or American Stouts, and they're favoring that because we know that he is preferring American beers. And that's all because we're leveraging the dimensionality of our data and not just trying to run averages and produce, our most recommended or most reviewed beers. So now let's take a step back and say, okay, if we wanted to do these two sort of seemingly simple things that we've made simple with all of this effort, how would we do that? And it all starts with labs, as Kyle mentioned. So labs is the place where we can bring our domain expertise into the system and then leverage it at scale against our data. So using a representative set of documents, we can perform annotation tasks. And what annotation is it's identifying so that we can extract the entities and relationships that we care about. So if I come in here, I can see that we have aspects like light orange color, which is a piece of appearance. And so I'll identify that and match all within my document set. And I can say citrusy, maybe this is a flavor. And I want to annotate that as a flavor. And as we keep going through, we can say there's orangey taste. So let's annotate that. As one last example as a flavor. We don't have a glass type in this review, but we could also annotate class type. And so once we have our domain expertise, our beer experts come through and define the important pieces, instances of flavor, appearance, texture, and glass type, we can then create a version of that, which is basically creating a training set. So for those of you who have very advanced NLP capabilities, we can actually just export and download training data. So you can run entity relationship extraction models or named entity extraction models. Or within Hume, we can actually one-click create an entity extraction model, which I have previously done, and create a skill. And a skill is basically, think of it like an Amazon Alexa skill or something similar, where we have a tool that we want to leverage in other places in the application. We've done all this effort tagging our data with our domain experts, and we want to be able to leverage it someplace else. So we'll create a skill to be able to do that. Once we've created that skill, we go back to our knowledge graph and we can start leveraging Orchestra and start filling in our data based on our NLP. And so as you see, we're actually pulling this from existing Cipher within Neo4j. And we have our entity extraction skill, which you can see is still called the beer skill. And it's going to pull out entities and submerged entities and other annotations. But then also within Hume, we have a standard piece of IP, which is Hume text rank, where we're using basically the sentence structure within a graph to identify keywords. And as we see when we go back to our schema, these all fit into our graph alongside our structured data. We have our users who have written reviews, and those reviews have mention a beer, and those beers are in brewers and styles, all of that structured data, and it's sitting alongside almost indistinguishable from data that we've extracted with NLP, like texture, class type, flavor, appearance, and keyword. And that really comes down to what we see as the strongest power of knowledge graphs, where we've been able to take domain expertise, extract extremely valuable pieces of information from our unstructured data, and store it alongside our structured data in the graph to leverage both of them. Because as we're making recommendations, we're going to care about both the review scores, so looking at the score on palate and taste and aroma and appearance, as well as what kind of appearance was there. Because when we're recommending beers to Mike, he might prefer really hazy beers, whereas Sally might prefer really clear beers, and rate them differently. We want to be able to leverage those pieces of information. So as we come back into our visualization and dive into this in a little bit more detail, I just want to highlight the power of this in terms of leveraging our annotations at scale. As I created this demo, I annotated about 100 reviews and found 6 examples of glass type. And so when I pull this up and you see that we have 400 instances of glass type within the system, we can see that we have a pint-sized Pilsner glass, a 12-ounce glass tumbler, a wheat glass, a 12-ounce brown glass, a pint bottle. We have all these different instances because our NLP model has been able to identify how a glass is referenced within text and extract that from our unstructured data. And the same thing has happened with our appearance, flavor, and texture. And so I didn't annotate, this is not a dictionary lookup where we've said 517 things are appearance within a graph. We can bootstrap with a dictionary, but in the end, we're going to want to create a model, and Hume lets you do that very quickly. And so now if we go back to our original similarity use case, we have our blue moon Belgian white. We'll run our same query here to get the same results. And now once we get these results, I want to take the next step and actually explain this similarity. Because as we mentioned, there are some results coming up here that don't necessarily make sense to us off the top of our head. So we have some ones that do, but if we come out to this Brooklyn East India Pale Ale, maybe what I want to do is I want to explain the similarity between these two, because an East India and East IPA is not intuitively similar to me to a Blue Moon. So I'm going to come and I'm going to explain similarity. And because all of this data is in a graph and we have that unstructured data alongside our structured data, we can actually see what pieces of the reviews are being extracted and that describe these two beers, as well as actually visualize how important they are to the two reviews. So as we start looking through here, we see that we have some instances of taste. We've got a taste of coriander, which is very light. We have a weight of about 11,000, which is small on our scale. But we have some very popular instances of citrus and orange and sweet, as well as they're both sort of hazy and cloudy beers, but they're also kind of light and smooth. And so now, even though an IPA and a Belgian white don't off the top of our head seem very familiar, very similar, once we're able to look at the unstructured data connecting the two of them, we can see that these actually would be incredibly good recommendations. And if we take a step back here and think about from beginning to end what we just did here, we were able to capture our domain expertise into the system, into the platform, and leverage it at scale. We've seen instances of organizations where they've tried to do this, and really they've gone through all this effort to annotate documents and ended up with like an Excel file or a TSV file stored on someone's laptop after spending hundreds of man hours and massive investment on getting their legal team to annotate regulatory documents. That's a really dangerous way to play. And within Hume, all of that information is stored and versioned within the system. We've then taken that expertise and been able to leverage it against our unstructured data and store the results into our database. Now it's something that we can leverage automatically, or not automatically, but very easily, as Kyle was mentioning, against applications. This application, this database, and here we're using actions, but we might have an application where we have a front end that's recommending beers or recommending products or reviewing our employees or whatever it may be. That data is all available to us. And then most importantly, we've taken this amount of effort, which is normally measured on a months and a years spectrum, and moved it down to days and weeks. We've taken the time to value from long to incredibly palatable, which is increasing the ROI on any investment into knowledge graphs and NLP. That's one of the biggest things that we've seen, and actually you have a presentation at Nodes 2020 recently about investment into NLP and being able to start with smaller bite-sized chunks so that we can get value rather than trying to boil the ocean. And cutting down that effort and leveraging NLP on our unstructured data to create more dimensions on our sparse data sets allows us to achieve incredibly powerful results. And we can do that much faster with Hume. Back to you, Kyle.
Thanks, Will. Let me go ahead and share out. So you should be seeing that demo slide. I'm advancing now to some example knowledge graph use cases. And this gets into the question of how does this drive value for your unique organization? Okay, and this is about planting seeds and sort of giving you examples of what other companies and what other organizations have done leveraging this emerging technology. So for example, we actually worked around a concept of how could you match, this was with a cancer institute, how could you match patients to trials? It's hard to imagine a more important activity than taking, a family member of yours and being able to connect them somehow to an unfolding trial that could uniquely address what they're facing. And there's really never been anything like a knowledge graph to be able to drive that kind of outcome. So there's a really, really cool and impactful example. Again, lots of unstructured data with patient records and trial information and so forth. Next, defense. Okay, so we've got an example of managing across millions of research articles and emerging defense requirements and looking how can we match those up, right? Huge level of effort without having a capability like this to build and manage a knowledge graph and deal with and actually work on the ingestion side as well. Energy, mapping oil wells to parts, maintenance, documentation, lots of unstructured, right? Cruise company, and I'm gonna pause on this one because I mentioned it earlier in the overview, connecting emerging legislation with massive fuel buys across disparate holding companies. I just thought this was one of the most interesting examples I've ever heard. We're talking about a multi-billion-dollar company whose one holding company is responsible for doing large fuel buys to save money, right, multi-year, and they went ahead and did a fuel buy at a certain grade, and then meanwhile, where they sail in Europe, legislation was released at the same time that prohibited that fuel grade that they just bought a multi-year purchase of. And it was a real life example. And if there was some way to harvest things like unstructured data legislation that could really be impactful to my business, like tangibly impactful to my business, my bottom line, connect that up with activities and other unstructured data from inside of the rest of my company, and then somehow actually suggest that to an executive to look at, that is a needle in a haystack that would be incredibly valuable to know about. Not possible really at scale before knowledge graphs. Retail, enriched and more targeted e-commerce recommendations. So if you think about products, some products are very simple. Some have lots of unstructured data. All of them have reviews, which are unstructured and related kinds of information. Others have documentation, right? Just bringing in that incredibly important unstructured side of the equation can make all the difference. HR department, identifying top 100 must-keep employees out of tens of thousands. If you think about the job of an HR department to really make sure to keep the workforce intact and happy, it's really important to be able to somehow understand, maybe out of tens of thousands of employees, who are the ones who are having the outsized impact on our organization. And if we lost them, they would also have an outsized impact on our organization, maybe going to a competitor, for example. So by harvesting all kinds of unstructured data from inside the company and understanding who are these top contributors, it's a huge value add. Banking, managing duplicative compliance efforts across the world. This is a massive, massive cost to banks around the world, right? Similar kinds of compliance, different kinds of, whether it's Sarbanes-Oxley or other kinds of contexts in which they have to do the same thing over and over. Fleets, managing parts and maintenance documentation. Another example is security. We talked about defense already, but intelligence, policing, there's all kinds of really important applications for this, identifying bad actors and time to actually, or situations or context and actually time to make a difference, right? And so those are just some examples. There's tons more, but these are some of the ones that we've come across over time. We thought it would be helpful and valuable just to kind of plant some seeds. And from here, I want to kind of bring it in for a landing by doing a quick poll, and then we'll go to question and answer. So I'm going to launch a poll. It's very simple. It's yes, no, right? Does this webinar help me? Did it help me understand knowledge graphs better? So it's my first time actually using this. Hopefully it works out, and you can just go ahead and start answering this. And then we will advance to the Q&A. So we'll give this just a minute. and start looking at some of the questions. Now, one of the questions that was asked and answered, and you can, any question that was not answered live, that was answered in writing, you can see under the answered tab within the Q&A window. And there was one in there, are there memory limitations to processing? And Will has actually answered that question. So I'm going to go ahead and see if there's another one here. So you can read that one. How do we handle temporal data? We'd like to see how that plays out in knowledge graphs. You're welcome for the presentation. And that's, temporal data is obviously a really, really significant topic, right? And the implications inside of graph are not insignificant either. I will say this, there are techniques that we've used and are using and are evolving actually to really use temporal data in a graph context. There might be other contexts where you could use time series databases and so forth, but there's amazing applications for temporal data inside of graph. And I think probably beyond the scope of this particular call, but if you'd like to find out more and find out what we've done and how we've solved for that, that challenge, we'd love to talk more about that. Another question that came up, how do you handle tracking changes in the information? Are you still able to show a change history? So, within Hume, the platform, it's definitely tracking those changes and versions over time. So, you can certainly excise the data over time that you don't want, but by default, there's definitely an ability to sort of keep track of what was so that you can see what is and what's changing over time. I'm going to leave that one up because they've also answered that in writing. This time doesn't look like there's a ton of other questions out there. I would like to leave a little bit of time. I'm going to end the poll now. Thanks everybody. It looks like overall we got favorable sense of the value of the presentation. So thank you for that feedback. I'd like to point out that you can reach out to us anytime through the website. We've actually got a blog that you can sign up for. It has our events as well as our blog articles on related topics. And you can reach out directly to Matt Bram. There's his email as well as our overall phone number. And if you didn't get your question answered in time, or you want to talk to us in more detail about any questions at all, we'd be happy to do that. And Matt can set that up. We'll get the right people on the phone to have that discussion. So overall, thanks for spending your lunch with us. I hope everybody's staying safe, and we look forward to an opportunity to catch you on the next webinar. Thanks, everybody.